So in the previous video, I walked you through the basic idea behind geological modeling in RMSP, and I showed you a very, very quick example, just really showing you how it works. I introduced the geo training set. So what I'll do is I'm just going to expand a little bit on that, because this is a very useful training set to be used for geological modeling training. So basically what it is, within RMSP we have a number of training data sets or example data sets. For geology, we have the geo training 1 set, although other data sets can be used for geology as well. The geo training 1 data set is a set of points with drill hole ID from to XYZ, all that sort of information you would expect, as well as rock type, oxidation, and fault attributes. It's loaded as point data, but can be easily converted to interval data using the toInterval data method. Then we also have structural data. This is loaded as a pandas data frame and can be converted to structural plane data pretty easily. And it consists of XYZ coordinates, strike, dip, and facing directions. The facing direction basically being an orientation, dictating which side is inside and which side is outside of that structural measurement. The dataset also has labeled structural type, identifying what type of structural measurement we're looking at, whether it be a contact, a foliation, a fault, or anything like that. Both these datasets belong to the single vein dataset, which has collars, surveys, assays, composites, a vein shape, and a topographic surface. The vein shape obviously a little bit redundant here, as we will be creating those using geological modeling. The rock types here are synthetic, but can be thought of as follows. Like I think of this as a skarn system, and it's so we maybe we have like a basement lithology, like a granitoid or something, considered our background lithology, and then we have code 2, which is a major lithology overlying that basement lithology. Maybe that's a limestone or dolomite or something like that. Code 1 is a feature which is later than code 02. Maybe that's our skarnification, which is destroying the contact, or overprinting the contact, I should say. And then we have a later or synchronous with code 1, and that this is a subparallel gold-rich narrow tabular but continuous feature, like a massive sulfide or a quartz vein or something like that. And this basically represents the domain of economic significance, and we have corresponding gold grades associated with this. We also have a post-mineralization swarm of dikes striking towards the northeast. There's a number of them, and they don't form one particular structure. This is a pretty common feature that we get in geology, and very difficult to model because they're very narrow. So it would require a very high resolution if we were using something like surface modeling, but also quite cumbersome to flag manually to create veins. Obviously, the advantage being is that if you can flag these in RMSP, you can always create a loop to create these veins. Then we have code 5, which is a supergene oxidation horizon, either lumped as overburden or can be broken out by oxidation intensity using the ox column. Lastly, we have a fault column, which consists of 2 faults cross-cutting all units except for the late dikes and the overburden. Okay, so what we will do is we'll just demonstrate how to load the data in this next part of the video. Okay, so firstly we're just going to have a look at our load example data function in RMSP. So if we just press Shift Tab, when we open that bracket, we can see we've got a whole lot of different data sets here. And over here we have our geo training 1 data set. So we can just put that in quotes and load that. I'm also going to load topography. Now the topography exists in a data set which actually has composites, a vein solid, and the topography is the last in a tuple when you load it. So what I'm going to do is I'm just going to assign those first 2 objects to underscore, meaning I'm assigning it to nothing. And then I'm going to again go and load example data. And this time I'm going to load single vein dataset. Okay. Last thing I'm going to do is I'm going to load the structural data. And this is simply called structural data. Let's load our example data. Structural data. And let's just do some quick previews of this. Let's go display data.head. Let's get to, and let's put another one here. Display structural data. Head and give it first direct of that. Okay, so there we see we've got our two different data types. You can see we've got those columns, oxidation, rock type faults in that data set, and here we've got our structural data set with XYZ structure facing and structure type. So let's do some processing, and I'll show you why we want to do some processing. Because if I say type data and type structural data, you can see that this is point data and this is point data. Okay. So we actually want to convert the structural data to structural planes, and we want to convert this data to interval data. The reason why we want to convert this to interval data is because for many geological modeling processes that we want to do, we need to understand where the contacts between lithologies is, and that information we can get from interval data, which has information on the start and end coordinates of the intervals. So let's go data equals data dot to interval data, and then let's convert our structural data equals RMSP dot structural plane data, and let's give it our structural data. And we can fill in a whole bunch of information about this. So, for example, we can fill in the structure and facing, X coordinates, the Y, and the Z. Oops. Okay. And that should be all we need. Okay. Now we can just plot this data up. We haven't created any domains or anything, so it's just going to plot them with those original codes. If we wanted to map those codes to anything, we would first define a domain subject. So data.view3d, and let's say we want the rock type column to be shown, and let's make our tube radius 2 so that we can see some other information, and the tubes are not too big. Okay, then we can go v.add. Let's add a topo and just give it an alpha 0.5, let's say, and then we could go and show our structural data. And the structural data has various ways of adjusting how they look on screen. So what we could do to set our view equals v. The v.add will not work with structural data at this moment. So the radius. So what we can do is we can set the radius of our structural data because they're going to be shown as disks, and then we can set the thickness, and let's just set the thickness to 2. And let's just go ahead and view this in the interactive view. Okay, so there we've got our interval data with our different rock types. You can see the little purple guys are those little sporadic sort of late dikes going through there. You know, you could call this the granite at the bottom. This would be the dolomite, whatever the type of skarnification. And if you look carefully here, you'll also, if we just turn off the structural data, we've got these red intervals which represent that continuous massive sulfide vein. And then we've got our brown, which is the overburden. So, you know, quite a lot in there to be able to model some geology. And if we wanted to, we could go ahead and set preferred views. So say I want to look at this, copy v dot set camera, and then I could make that as static. There we go. Okay, and in the next video we're going to be talking about some processing of data.